Greetings. Today we are going to learn about test for cations, and basically we're going to use these two reagents that have been confusing very many learners, that is sodium hydroxide and ammonium hydroxide, which we have here provided in our beaker, and they are having a dropper. So we are going to test them using different cations, that is calcium, magnesium, aluminium, zinc, iron 2, iron 3, lead 2, copper 2, and barium. And actually, before we begin our experiment, we are supposed to know that these three cations, that is copper 2, iron 2, and iron 3, are colored. Just look at their color. Copper 2 is blue in color, iron 2 is green in color, and iron 3 is brown in color. Therefore, follow up with us as I'm going to guide you through this test. Thank you so much. And in this step, I'm going to show you how to take your observation. And here, I've just added this because already I have the tests of cations, so I don't want to place the inferences there. So here I'm going to place a tick. If there is a precipitate, I'll place a tick. If in excess it dissolves, I'll put an X. If it does not dissolve, it is insoluble, I'll put ticks. Thank you so much. Follow up with us. Okay, our test first, we're going to begin with the sodium hydroxide, which is here, and it is inside our beaker. And we have placed a dropper that we're going to use to place the drops inside our cations that already are provided here. So I'm going to start my practical by beginning with calcium, as I'm just guided here. I have a formula that I normally use for these cations, that is Kamgazin, Fefe, Bukuba. So if you just have that, you'll be in a better position. Kamgazin, Fefe, Bukuba. So I'll start with calcium. This is calcium ions. And these calcium ions, I have just subdivided it into two. So I'll start by using the one that is not treated, so that when I'm getting to the next practical, I don't confuse myself. And I'm going to take my sodium hydroxide. After taking my sodium hydroxide, I'm going to add some 3 drops. Just see. First drop, you are seeing something that looks like clouds. And it is white. That is a white precipitate. So when you add 3 drops, there is a white precipitate, and that is what you write in observation. White precipitate. And now you can be told to add in excess of sodium hydroxide. What will happen? In excess, we mean it can be the equal amount. If this is 2 ml, you add exactly 2 ml. So we are going to add it in excess to see what happens. So the white precipitate is insoluble in excess. It's like it is increasing. Its intensity is increasing. So you say insoluble in excess. So what do we do on our table there? Drops, we have a white precipitate. In excess, it is still there. So that is addition of sodium hydroxide and calcium. I'm going to get to the next test. We're going to use magnesium. Remember, I have to remind you, I have my own acronym of Kamgaz, Zin, Fefe, Bukuba. So I'm getting to magnesium. Now, this is my magnesium that I've labeled, but I'm going to use the one that I've not labeled, so that when I'm going to repeat the experiment using ammonium hydroxide, I'm not going to confuse myself. I've told you the reason why I've done that. So again, I'm going to add a few drops, like 3 drops. So this is magnesium ions. I'm adding a few drops. I'll move it closer to the camera so that you can see. The first drop, second drop, and the third drop. You're seeing some clouds. And those clouds are the ones that we call white precipitate. So we write again white precipitate. And then we are going to add excess. We're going to add excess sodium hydroxide. That is excess. So the white precipitate does not dissolve. So we are going to say what? Insoluble. Because we know solids that are not soluble are called insoluble. So also it is insoluble in excess. So we are going to put ticks there. We proceed to the third. Again, our acronym. Kamgal, Zin, Fefe, Bukuba. So we are getting to aluminium. Aluminium, back to our test. One is labeled, the other one is not labeled. Why have I not labeled it? Because I just know it for now. But when I'm going to repeat the practical, to avoid confusion, I have labeled the first test tube. So this is aluminium ions. Again, I'll add some few drops of sodium hydroxide. So few drops. That is the first, second, third. Are you seeing the same crowds? Yes, they are there. Those white clouds, I've told you, they are not called white clouds, but they are insoluble substance, which is identified as a white precipitate. A white precipitate. Now I want us to see, it is here with us, white precipitate. What will happen when I add excess sodium hydroxide like that? So I'm adding excess sodium hydroxide. Something is happening. I want you to be very keen on it. The white precipitate is doing what? It has dissolved. So when something dissolves, we say it is soluble. So you can say soluble in excess. So here, white precipitate, soluble in excess. Now, why is it soluble? Yet we know magnesium hydroxide is an insoluble hydroxide. This is due to the formation of a complex ion. We have it here, a complex ion. The complex ions that are formed by sodium hydroxide are here, the hydroxide complex ion. And the naming for this is called hydroxo. Aluminium, as we all know, it is having an oxidation value of 3, state of 3, it has a valency of 3. So we have to tell the ions, they are 3 ions. So the naming is like this. 4 is called tetra. And we have 4 hydroxo. So it is tetrahydroxo. Now the name for this ion is aluminium. And because we know aluminium has 3 ions. So this is the name of this complex ions. So if you look at the 3 tests that we have done for up to this moment, is that for calcium there was a white precipitate insoluble in excess. For magnesium, a white precipitate insoluble in excess. Aluminium, a white precipitate dissolves in excess. And that is why labeled, so that we can avoid confusion when we are going to carry out the second test using ammonia. We are proceeding to zinc. Now what happens when I'm going to add my sodium hydroxide dropwise in zinc? So those are some drops. That is a white precipitate. So we write white precipitate. And this white precipitate, what will happen if I add excess sodium hydroxide like that? Remember, excess is when you add equal amounts of the solvent used. So what is happening? The precipitate is dissolving. I want it to be clear to you. you can see it is like disappearing. That's why it realize that at the end of the day, you're going to see it. So again, we say white precipitate, either you can say soluble or dissolves in excess. So again, a tick and a cross. Why does it dissolve in excess? Again, due to the formation of a complex ion that is called for tetra hydroxide zinc as makes a valency of two, so zinc 2 ions. So the name is tetra hydroxide zinc 2 ions. They are the ones responsible for this precipitate dissolving. Now we are proceeding to lead. I'm skipping iron because it is colored. I introduced it. So Kamgal, Zin, Fefe, Bukuba. But we know iron 2, iron 3, and copper, they are colored cations. We're going to look at them, of course, and we are going to see what is going to happen. Okay, now we want us to look at lead. And here is our lead. Of course, one of them is labeled, the other one is not. We're going to add a few drops of sodium hydroxide. A few drops. There is a white precipitate. So I'm going to write white precipitate. Then, what will happen if I am going to add excess sodium hydroxide like that? What is happening? The white precipitate dissolves. So, you can say either soluble in excess or dissolves. So, soluble in excess. Again, same trend due to the formation of a complex ion that is called 4 is tetra. This is hydroxo lead 2 ion. So the name is tetra hydroxo lead 2 ion. So these are the complex ions that are formed when we are using sodium hydroxide. And finally, we're going to look at barium, whereby for the case of barium, we're going to add some few drops. I'll say a white precipitate, though it is quite faint. What will happen if I add excess barium, excess sodium hydroxide in barium? So, it is insoluble in excess. So, we have our result. This is for the colorless cations, and those are the expected observation when you're using sodium hydroxide. Now we have the colored cations, Kufefe, copper 2, iron 2, and iron 3. What happens to these ones when we are going to add sodium hydroxide? So I'm going to start with iron 2. Iron 2 is here. It is green in color. Iron 2 is green in color. I'm going to add some drops of sodium hydroxide, and we want to see what will happen. So, there is a green precipitate. So therefore we say green precipitate. Now, in excess, what happens to this green precipitate in excess? It does not dissolve. So, insoluble in excess, that is what we see. So this is the test for ion 2. Now we want us to get to ion 3. Ion 3 is here, it is brown in color, and when we're going to add a few drops of sodium hydroxide, are you seeing a brown precipitate? So, brown precipitate. What will happen if we add excess sodium hydroxide? It's just there, so insoluble in excess. So here it is just precipitates. And then finally we get to our copper 2. What is going to happen to our copper 2? Copper 2 is blue in color. And this copper 2, we are going to add a few drops of sodium hydroxide. So what is happening to copper 2? There is a blue precipitate. And what happens to this precipitate when I add excess? So it is still insoluble in excess. And that makes us to come to the end of the test for cations using sodium hydroxide. This is how you take your observations and then the inferences. I'm going to guide you maybe next time on how to write the inferences, but now this table summarizes everything to do with sodium hydroxide, how it can be used to test for cations. I have left out potassium, sodium and ammonium because these cations are already soluble, so we cannot use them when we are testing for cations. Thank you so much, and now let me guide you through this table. Now in this table, what you're seeing here is that sodium hydroxide is going to form precipitate to all these substances, Camgal, Zin, Fefe, Bukuba. But we need to know the color of this precipitate. For the colored cations, green for ion 2, brown for ion 3, and blue for copper. And the rest are white precipitate. We have the complex ions that we normally abbreviate them with ZAB, that is zinc, aluminium, and lead. These ones are soluble in excess, and that is why you can see here there is an X when it comes to aluminium, there is an X when it comes to zinc and lead. Thank you so much, and now you can take your notes if you want to understand this more. After using sodium hydroxide and getting the results, we realize that most hydroxides are forming precipitate. Don't forget that in this experiment that we're going to proceed with, we're using ammonium hydroxide. So we are expecting similar results but somewhere we're going to see a difference, because the complex ions of ammonia are different from the complex ions of sodium hydroxide. So follow up again with us as we guide you through test for cations using ammonium hydroxide. We are going to learn together. Thank you so much. Okay, we are going to start with calcium, and we are going to add a few drops of ammonia. So, a few drops of ammonia. So there is a faint precipitate. In most exams, they tell you to add excess ammonia. So, what will happen? This one I want us to be very, very keen on it, because of the confusion it creates in most of the tests. So this precipitate is not evident, and I will give this reason. When you add a few drops of ammonium hydroxide, you form calcium hydroxide, and calcium hydroxide is a white precipitate. But when you add excess ammonia, the ammonium ions are going to replace the calcium ions to form ammonium hydroxide, which is no white precipitate. So in most of the exams, so you can write the first of course observation in drops. There is a white precipitate that is soluble in excess. So in the exam, if they give you in excess, just say no white precipitate. So there is a white precipitate that is insoluble in excess. We proceed to magnesium. Now, on the case of magnesium, here it is magnesium. We're going to add a few drops. There is a white precipitate. What about in excess? It is insoluble. So, white precipitate insoluble in excess. So here there is a white precipitate that is insoluble in excess. We are proceeding to aluminium. Aluminium. Now for the case of aluminium, remember I told you we don't want confusion. The ones that are labeled are the ones that we have not tested. So aluminium, we're going to add a few drops of ammonium. So there is those clouds. That is a white precipitate. Now what about in excess? In excess does not dissolve. So you say white precipitate insoluble in excess. We go to zinc, but before we get to zinc, I want you to show you the ones that are labeled. We have added ammonia. The ones that are not labeled, we added sodium hydroxide. You can see the relationship. For the case of aluminum, the white precipitate is there, but for sodium hydroxide, it dissolved. So we go to zinc. Zinc, add a few drops. White precipitate. What about in excess? What is going to happen when we add excess ammonia to a precipitate? Something is happening. I'm trying to shake, but I'm afraid because ammonia has a pungent smell, it might deal with me. Let me just do for the case of this experiment. What has happened? It has dissolved. So we are going to say Now my hands are quite smelly, quite precipitate, soluble or dissolves in excess. What is the reason? Due to the formation of a complex ion that is called this is amine. Tetramine, zinc, 2 ion. That is the complex ion that is formed that is soluble in excess of ammonia. We proceed to ion, but this one, because the alkali, I'll just go to lead. Now for the case of lead, we have our lead here. We add some few drops of ammonia, so there is a white precipitate. What about in excess? It stays, so we say white precipitate insoluble in excess. So it's just a continuous precipitate. And then we go to barium. Now what will happen to barium? We're adding a few drops of ammonia. No white precipitate. Excess, no white precipitate for the case of barium. So no white precipitate. Now, calcium and barium, in excess of ammonia, there is no white precipitate. And mostly in the examination, they'll just tell you add excess of this ammonia solution. Now we are going to get to the colored. We have our colored cations here. You can see the case for ion 2, it has still a dirty green precipitate there, but it has turned brown because of oxidation. Remember, this is ion 2. It can easily get oxidized to ion 3, which is brown. And these are the ones that we tested. Now we are going to proceed by using ammonia. We start with ion 2. Ion 2 is green in color. We are going to add a few drops of ammonia, then again in excess, a few drops like that. So after adding a few drops, there is a green precipitate. Now what about excess? It is forming a dirty green precipitate. Dirty green precipitate. It is quite insoluble. So that is what we write. In few drops it is a green precipitate. You can still say insoluble in excess, or which forms a dirty green precipitate in excess of ammonia. So that precipitate stays. We go to ion 2. Ion 3, I mean. Ion 3 is brown in color. We're going to add a few drops of ammonia like that. There is a brown precipitate, and now what is going to happen if I add excess? When I add excess, the precipitate does not dissolve. So we're going to say brown precipitate insoluble in excess. And then finally, we are going to get to copper 2. Now copper 2 is blue in color. We're going to add a few drops of ammonia. So there is a blue precipitate. blue precipitate. And then what will happen if we add excess ammonia? It dissolves, forming a deep blue solution. Forming deep blue solution. Where does it dissolve? Due to the formation of a complex ion that is called 4 tetra NH3 amine copper 2 ion. So it is tetramine copper 2 ions. And this makes us to come to the end of our presentation. Now finally, just look at the color changes that have happened here. The labeled ones, we added ammonium solution. The ones that are not labeled, we added sodium hydroxide. You can see the differences. They are evident there. And this is how we test for cations in the laboratory. Thank you so much. Again, I'm going to take you through these notes using ammonium hydroxide. There they are.